In this video, we discuss data types concept. Data types are used to declare variables or functions of various types. In C language, if you want to declare variables, if you want to declare functions, then we must specify type for those variables or functions. Data types, they also do another functionality. They assign memory locations to variables. They provide required amount of space to variables. And the size of the memory allotted to variables, they differ based on their data types. In order to understand data types concept, we see a simple example. There are 4 items here: wrench, clock, computer, and a bus. If we want to store them, if we want to store all of them in our home, do they occupy same amount of memory? What is your answer? No. Wrench occupies small amount of memory. Clock occupies some more amount of memory than some more amount of space than wrench. Computer occupies more space. And out of these 4, bus occupies huge amount of space. That means all these items are occupying different amount of spaces. All of them are not occupying same amount of space. Similarly, in a C programming language, if you want to store different types of constants in a computer system, then each and every constant contains its own memory requirement. Each constant has its own memory requirement. That means all the constants do not occupy same amount of memory. What are those constants we are having? If you want to more details about those constants, you can see the video about constants which I have made. Now take integer constants, character constants, floating point constants. All of them occupy different amount of memory. So in order to specify or in order to allot memory to those variables, we use data types. So coming to data types, they are categorized into different categories: primitive or basic data types, derived data types, enumerated data types, and void data type. In this video, we discuss primitive data types. In the later videos, we discuss derived and other data types. Now, what are those primitive data types? Okay, in this video, I will clarify difference between primitive and derived data type. Primitive data types are the basic data types, and derived data types means they are derived from the basic data types. Primitive data types are classified into 2 types: integer types and floating point types. And derived data types are arrays, structures, unions, functions, pointers, etc. And coming to integer data types, so this comes under primary data types. So there are different categories here. Character also comes under integer data types: char or signed char. So char, this is the basic data type. Char, it is also called as signed char. Signed char. So that means it occupies 1 byte of memory. So now see this here. Memory allotted in bytes. It occupies 1 byte of memory. And the range of values it supports is -128 to +127. That means signed means here it allows negative values as well as positive values. So minimum value we can give here is -128, and maximum value we can give here is 127. That means in a character range we can give values from -128 to +127. And the format specifier which is used for printing a character value or a signed character value is %C. At this point, remember all these format specifiers. In the later videos, we see how to use them to print values. Coming to unsigned characters, unsigned means there will be no negative values, only positive values. Again, unsigned character occupies 1 byte of memory, and the range of values are 0 to 255, and the format specifier used is %C. Coming to next one, short integer, or it is also called as short signed integer. We can use it interchangeably. We can use either short int or short signed integer. So it occupies 2 bytes of memory. So all these specifications. Okay. Now it supports range of values -32,768 to a maximum positive value 32,767, and the format specifier used is %D. Coming to, so we have completed 3 things. Coming to next one, short unsigned integer. Unsigned means, as I said in the previous case, it contains only positive values. Again, short unsigned integer occupies 2 bytes of memory. Its range of values are starting from 0 to 65,535. And the format specifier used for printing this value is %u. Next one, integer, or it is also written as signed integer. It occupies 2 bytes of memory or 4 bytes of memory. So these sizes are compiler dependent. Suppose if you use 32-bit compiler, it will assign 2 bytes of memory, or if you use uh, uh, or it will assign 4 bytes of memory, or if you go for 64-bit compiler, it will assign some other amount of memory. So all these bytes allocation are dependent on the compiler. So next one, its range of values are, suppose if a computer gives 2 bytes of memory, then its range of values are minus 32,768 to 32,767. Suppose if it allows 4 bytes of memory, then its range of values are minus 2 147 483 648 to 147 483 647, and the format specifier used here is %d. And next one, unsigned integer. In unsigned integer, again it is compiler dependent. Compiler may allow 2 bytes or 4 bytes. It depends on the number of bit compiler, 32-bit or 16-bit compiler or a 64-bit compiler. Suppose if it allows 2 bytes of memory, then range of values are 0 to 65,535. Suppose if the compiler allows 4 bytes of memory, then its range of values are 0 to 4294 967 295. And the format specifier used here is %u. Next, there is another category, long integer, or it is also written as long signed integer. So again, it allows 4 bytes of memory or 8 bytes of memory. If it is 4 bytes of memory, this is the range. If it is 8 bytes of memory, then this is the range. And format specifier used here is %ld. And unsigned long integer, so again it is 4 bytes or 8 bytes. So this is the range for 4 bytes, and this is the range for 8 bytes. And the format specifier used here is %lu. And one more point, %c is used for printing a single character, but in order to print a string value, that means in order to print a group of characters, we use %s format specifier. Next one, floating point data types. In floating point data types, we have 3 categories: float, double, and long double. And the memory allotted here is 4 for float, 8 for double, and 10 for long double. So these are the ranges for float, minus 3.4e 38 to plus 3.4e 38. So all these are different ranges here. And the format specifier used for printing a floating point value is %f, and for double value small l f, and for printing long double value it is capital L f. And the precision values, that means the number of decimal points. Float supports 6 decimal places, double supports 15 decimal places, and long double supports 19 decimal places. So what we have learned in this video? In this video we have learned about different types of data types, what is a data type and what is the purpose of data type, and what are the different categories of data types.